Hello and welcome to Revision 3 for prep1. Here in this example, D and E are the midpoints of AB and AC respectively. Look here, E is the midpoint of AC here, and D is the midpoint of AB. And F belongs to CB ray. F belongs to CB ray in the direction of CB. Okay. And we have a given here, BF is half BC. So we have D and E are the midpoints of AB and AC respectively, and F belongs to CB ray, and I want to prove that BEDF is a parallelogram. Look here, just focus on this triangle ABC. Focus on triangle ABC. Okay, as you see here, D is the midpoint of AB, and E is the midpoint of AC. So we have midpoint and midpoint. We have midpoint and midpoint. D is the midpoint in this triangle, and E is the midpoint of AC. So the line segment joining between the two midpoints of two sides of a triangle is parallel to the third side and equals half length of this side. So let's focus again on this triangle. The triangle is ABC. Here A, B, C. D is the midpoint of AB, and E is the midpoint of AC. Then what we deduce? We deduce that DE is parallel to BC, and DE equals half the length of BC. Equals half the length of BC. Okay. So once again, we have D as a midpoint here of AB, and E as a midpoint of AC. So DE is parallel to BC, and DE equals half BC. This is number one. We have an important information here. F, since F here belongs to CB ray. Because F belongs to CB ray, then ED also is going to be parallel to BF, because BF in the same extension, in the same direction of CB. So ED is parallel to BF. ED is parallel to BF. ED also is parallel to BF. And if we looked at the given, we have here BF equals half BC. Let's focus on it. Since BF equals half BC, here BF is half of BC. And I proved that ED is half BC. So DE is half of BC and BF is half of BC. Then we deduce from them, from these information, we deduce that ED equals BF, because let's assume that BC equals 10. It's not right, but I'm assuming that BC 10. So ED equals 5, okay? And BF is given as half BC, so BF equals 5. It's not 5, by the way. So what I want to say is that they are equal in length, okay? They are equal in length, and they are parallel. So from that, we have two sides here. The two sides are ED. The two sides are ED and BF. They are parallel and equal because ED is parallel to BF and ED equals BF. So we can deduce that the figure BEDF is a parallelogram. BEDF is a parallelogram. In this example, D is the midpoint of AB, as you see here. Just read and focus on the drawing. D is the midpoint of AB and E is the midpoint of AC. Okay, so we have midpoint and midpoint. Let's analyze it here, midpoint and midpoint. I've drawn only triangle ABC, and here D is the midpoint and E is the midpoint. DF intersection BC equals X, and DX equals XF. Here, DX equals XF. I want to get the length of XY here. So let's take it step by step. Because E is the midpoint and D is the midpoint, so ED equals half length of BC, and ED is parallel to BC. That I want to say. Since D is the midpoint, D is the midpoint of AB, and E is the midpoint. That is the reason. D is the midpoint of EC. So we have two reasons here. D is the midpoint and E is the midpoint. Then DE equals half length of BC, and DE is parallel to BC. So DE here in this case is going to be 6 because BC equals 12. So DE, sorry, equals 6 centimeters. And now let's focus on triangle DEF here. Focus on triangle DEF. Here is triangle DEF. D, E, and here F. And we have XY here. X is the midpoint. X is the midpoint. And we reach that DE equals 6, so right here 6 centimeters. So D is the X is the midpoint because X is the midpoint. But what is the question now? Is XY parallel to BC? Yes, they are parallel because I proved that DE is parallel to BC. Once again, I proved that DE is parallel to BC and XY is a part of BC. So since XY subset of BC, the line segment XY subset of BC, and DE is parallel to BC, and from that XY is parallel to, we can say that XY is parallel to DE. Now let's focus on this triangle here. XY is parallel to DE. So we have X as a midpoint, and XY is parallel to DE, so they are parallel. So we can deduce that E is the midpoint of BF. Y is the midpoint of BF because we have midpoint and we have parallel. The ray which is drawn from a midpoint of a side of a triangle parallel to another side bisects the third side. So we write here the reason. What is the reason? Its sense means because X is the midpoint, of DF, and XY is parallel to DE. Then we deduce that Y is the midpoint. Y is the midpoint of EF. Y is the midpoint of EF. So here, because Y is the midpoint of EF, now the third step in this equation, in this question, I reached that Y is the midpoint of EF, and because Y is the midpoint and X is the midpoint, so right here at the end, because X is a midpoint and Y is a midpoint, okay, in this triangle here, X is the midpoint, I reached that X is the midpoint, and Y is the midpoint. So XY is equal to half of DE. And DE equals 6. So XY in this case is going to be 3 centimeters. I'm going to try it again since X is the midpoint of DF and Y is the midpoint of EF. So XY equals half DE equals 3 centimeters. That's it. ABC is a quadrilateral in which X, Y, Z, and L are the midpoints of AB, BC, CD, and DA respectively. Prove that X, Y, Z, L is a parallelogram. What we have studied in this area, that if we have a triangle, and we have a line segment joining between two midpoints of two sides of a triangle, then this side here, midpoint and midpoint, this side here is parallel to the opposite side of this triangle. This line segment here is going to be parallel and equals half that we have studied here. But here we don't have a triangle. We need to construct a construction. So here we are going to draw, we can draw BD. Now let's have a look at this triangle. This triangle here is ABD. This triangle here is ABD. Okay, just to focus on this triangle only. I constructed BD. So here we have a triangle and X is the midpoint, as you see. L is the midpoint. So L is parallel to BD, and XL equals half BD. So I'm going to write, since X is the midpoint, X is the midpoint of AB, and L is the midpoint of AD, then XL is parallel to BD, and XL equals half BD. Okay, let's have a look at the other triangle. Here we have, in this triangle here, we have the triangle BDC, this triangle here. Look at this triangle work. The triangle we want to focus on, it's triangle, let's color it in yellow. Okay, this triangle here, we have Z as a midpoint of DC, and Y is the midpoint of BC. So ZY is parallel to BD, and ZY equals half length of BD. So write in triangle BCD, Y is the midpoint. Y is the midpoint of BC, and Z also is the midpoint of DC. It's given. So we deduce that ZY, then ZY is parallel to BD. ZY is parallel to BD, and ZY equals half length of BD. So here we have XL parallel to BD, and ZY also is parallel to BD. So both of them are parallel to one side, XL and ZY. Both of them are parallel to BD. And XL equals a half length of BC, and also, sorry, it's BD here. It's not BC, it's BD, half length of BD. XL is half length of BD, and ZY here is half length of BD. Okay, half length of BD. So we deduce that XL is parallel to ZY, and at the same time XL equals ZY. Once again, because they are parallel to BD and both of them are equal to half length of BD, so we deduce that they are parallel and equal in length. Because we have two sides which are parallel and equal in length, then XYZL is a parallelogram. XYZL is a quadrilateral in which measure of angle XYZ equals measure of angle XLZ equals 90. And we're given the sides here. I wanna find the length of each of X, Z, and ZL. So let's have a look at this triangle. We have right angle triangle, so we can use Pythagoras. Just determine the right angle, it's Y, and determine the hypotenuse. X, Z is the hypotenuse. So because in triangle X, Y, Z, measure of angle Y equals 90. So X, Z to the power of 2 equals xy to the power of 2 plus zy to the power of 2. So xz to the power of 2 equals 7 to the power of 2 plus 24 to the power of 2 equals 49 plus 576. Adding them leads to get 225. Then by finding the square root of 225, it will be 15 centimeters. Now let's have a look at this triangle. The triangle is XLZ. This triangle here, XLZ. Okay. Here in this triangle, we have found XZ, which is 15, which is, sorry, here it's 625. I made a mistake. So the square root of 625 is 25. Okay. So this side is 25 centimeters. Now let's have a look in this triangle. Here XL is 15 and XZ is 25. How can we find XL? ZL? ZL is not the hypotenuse, so we are going to subtract. ZL to the power of 2 is going to be XZ to the power of 2 minus XL to the power of 2. XZ is 25 to the power of 2 minus 15 to the power of 2. 625 minus 225 equals 400. So ZL equals the square root of 400 equals 20 centimeters. Here in this example, we have ABC as right angle triangle at B, okay? And BD is perpendicular to AC and AB equals 4 centimeters, BC equals 3 centimeters. I want to find the length of BD. So let's have a look at the triangle ABC. ABC is right angle triangle at B, okay? So we can find the length of AC. So AC to the power of 2 here equals 4 to the power of 2 plus 3 to the power of 2 equals 25. So AC is the square root of 25 equals 5 centimeters. Okay. Now here we want to find the length of BD. So to find the length of BD, you should be familiar with finding the area of the triangle. If I ask you to find the area of triangle ABC, the area is half times base times height. And the question now, where is the base, where is the height? We can take BC as a base, so AB is as a height. So we can find the area as half multiplied by 3 multiplied by 4. Half times 3 times 4 is 6 centimeters squared. Okay. Half times 3 times 4 is the base and the height. And also we can find the area of the triangle ABC by taking AC as a base. Look here, if we are going to take AC as a base, we are going to take AC as a base. So what is the height? The height is BD. Here is the height is BD. And we will get the same result, 6 centimeters squared. So what is the area of the triangle ABC? It's half multiplied by AC multiplied by BD, the height of the corresponding base. Or here we have a base, AC, and BD is the corresponding height. And the area, it's 6. So write instead of area 6, it's half multiplied by 5. AC is 5 multiplied by BD. So half times 2.5 here. Half times 5 is 2.5. So 6 equals 2.5 multiplied by BD. So to get BD, divided by 2.5 and divide here by 2.5. So BD equals 6 divided by 2.5 is 2.2 centimeters. The number of axes of symmetry of the equilateral triangle 3. The isosceles triangle is 1 and the scalar triangle is 0. The parallelogram 0 axis of symmetry and the rectangle has two lines of symmetry. The rhombus has two lines of symmetry, and the square has four lines of symmetry, and the trapezium, which is not isosceles, has 0 lines of symmetry. And the isosceles trapezium has 1, and the circle has an infinite number. If the reflection in a straight line transforms the figure to itself, then this straight line is called a line of symmetry or axis of symmetry. When it comes to the reflection, in the reflection we need a line, okay? It's the mirror line. And so the point is x and y. The image of the point x and y by reflection in x-axis. The reflection in x-axis just change y. So change y, change the sign of y, change y. So it will be x-axis, okay? Change the sign of y, it will be x and negative y. Like the point 3 and negative 4 by reflection in x-axis, change the sign of y, it will be 3 and 4. Change y, it will be 3 and 4. Reflection in y-axis, it change x. So it will be negative x and y. So if we have a point like 3 and negative 4 also, by reflection in y-axis, change x, change the sign of x. So it will be negative 3 and negative 4. And the image of the point, the reflection of the point xy in the origin point will be negative x and negative y. Change both of them. So the point 3 and negative 4 by reflection in the origin point is going to be change 3, it will be negative 3, and negative 4, it will be 4. In the translation, we have the original point, okay? And there is a translation happened to this point, so we'll get an image. So here the image of the point 2 and 5 by translation, x and y, it's x minus 3, y plus 1. So x minus 3, subtract 3, 2 minus 3, it will be what? Negative 1. And 5 plus 1, add 1 to 5, it will be 6. If the image, if I want to find the image of the point 2 and 5 by translation, here it's the point, by translation, 3 units in the positive direction of y. 3 units in the positive direction of y. What about x? There is no x. So 3 units in the positive direction of y, write 2 as it, then add 5 plus 3, it's 8. Okay, because there is no change in x, just 3 units in the positive direction of y. And if we have a point like this point 2 and 5, here it's the original point, and the image is 0 and 8. What is the mapping, or what is that translation happened here? 2 became 0, so we subtracted 2, and 5 became 8, so we added 3. So what is the translation happened? It's x plus negative 2, so x minus 2. And y here, 5 and 8, so y plus 3. That is the mapping or the translation. In the rotation, we need to know the direction. We have clockwise and anti-clockwise. Clockwise is negative, anti-clockwise is positive, and we need to know the center of rotation and the angle of rotation. So when it comes to rotation 90, so it's positive. Do you know rotation 90 is equivalent to rotation 90 is equivalent to the same as rotation negative 270. They are the same. And the rotation negative 90, it's the same as rotation 270. Okay, here if we look at this angle, it's 90 because we are moving in this direction, positive direction. And if you are going to take this direction, it will be negative 270. What is going to happen here in rotation 90? Just if you forget the rule, we can draw it, or we can imagine a point and rotate it 90, like the point 4 and 1. Try to remember it. If we rotated this point 4 and 1, if we rotated it 90 degrees, so this point will be negative 1 and 4. So in rotation 90, just the point x and y, the point x and y here will be negative y and x. Change, remember it, change second coordinate and exchange, change second, exchange. Change the sign of x, replace, change the sign of y, sorry, change the sign of the second here. The second is y, so it change its sign and replace, like 4 and 1, it change the sign of the second, it will be negative 1, then exchange or replace 4 and negative 1 will be negative 1 and 4. When it comes to rotation negative 90, it's the same as 270. If the point is x and y, so a change first, exchange, change the sign of the first and exchange. Try to remember it. Change first, exchange. Change x, it will be negative x and exchange. So it's y and negative x. So if we are talking about the point 4 and 1, by rotation, negative 90. The rotation is negative 90. It change first, change the sign of the first, negative 4, and exchange, it will be 1 and negative 4. That's it. When it comes to rotation 180, it's the same. Rotation 180 is equivalent to rotation negative 180. You will change the sign of both x and y. X and y is going to be negative x and negative y. X and y will be negative x and negative y. Again, rotation 180 is the same as rotation negative 180, just to change the sign of x and y. And the last rotation is the identity. The identity rotation, x and y is going to be x and y. And the identity rotation happens when we rotate positive or negative 360. So the image of the point 3 and 4 by rotation positive or negative 360, it will be also 3 and 4. Here in this example, we have ABCD is a square and F is the midpoint of AB. And here, this point, let's call it L here. And L is the midpoint of BC, G is the midpoint of CD, and H is the midpoint of AD. And I want to find the image of the triangle AHM by rotation 90. So to find the rotation 90, determine the direction here. Take it a vertex by vertex. So about the point M, rotation 90 about M. Rotation 90 about M. Okay. So here the point, here we are going to rotate about its M. So rotate A90. When rotating A90, rotate it 90, you will get here the point D, because this angle is 90. So when rotating 90, you will get D. Okay. So we'll write here D. And the rotation of 90, if we are going to rotate H here 90, here it's H. I'm going to rotate it 90. Look here, it's 90. I'm rotating it 90. Here H here in this place are going to rotate it 90. So we'll get G. We're going to get G. And the rotation of M is M because it's the point we are rotating about. So it will be DGM, triangle DGM. If I want to find the image of AHM by reflection in BD, here we need to know where is the line of reflection. Here it's BD, so determine BD. Draw a line here, BD. Here it's the line of reflection, okay? So we are going to find A in this line here. The reflection of A in this line here, it will be C. So here it's C. And the reflection of H in this line will be G. And the reflection of M in this line will be M. So it's CGM here. The image of AHM by reflection in BD will be a triangle CGM, this triangle here. Take it a point by point. What if was the reflection in FG? So here, FG, determine FG and draw the line. Here is the line we are going to reflect this triangle in. So what is the reflection of A in this line? It will be B. And what is the reflection of H in this line here, the line of reflection here? H will be L, and the point M will be M, because the point M lies on the line. What if it was the reflection in HF? So let's draw HF. Here it's HF. HL, sorry. Here it's HL. Make it HL. So here the reflection in HL. That is the mirror of reflection. So the reflection of A will be D. Here D. And the reflection of H will be H. Here. And the reflection of M will be M. It's triangle DHM. I hope you enjoyed this session. See you in the coming episodes. Goodbye.